Hello and welcome to this video. In this video we are going to talk about phase transition, which is important if you are studying thermodynamics or condensed matter physics. So today we will mainly discuss about first and second order phase transitions. Now if you look at this picture, which is of course AI generated picture, in this picture what do you see? What is the speciality about this particular picture? So here you can see water, you can see ice, and you can see clouds. So water is the liquid form, ice is the solid form, and clouds are the gaseous form. So same material can exist in different phases. So but now the question is, how does this phase change? How does water change phase from liquid state to solid state, or liquid state to gaseous state, or solid state to liquid state? So that is the thing. So of course if we talk about thermodynamics point of view, then the change of phase depends on thermodynamic parameters or variables like pressure, temperature, and volume. So when water is cooled down, it becomes ice. When ice melts, it becomes water. When water is evaporated, it becomes it achieves the gaseous phase. So now the thing is, phase transitions are of two types, first and second order. And in the last video we discussed about helium, liquid helium. So liquid helium also undergoes phase transition. I discussed in the last video, you can watch it. And yeah, let us begin this lecture. So in physics, phase transition describes the change between states of matter, as I have already mentioned. So like liquid to solid or liquid to gas. Okay, so water to ice, or water to gas, even gas to water, or even liquid to solid. Okay, in case of water, for example, if we have gaseous gas, so how will it become water? By condensation it will become water or a liquid. Okay, similarly, if you cool water at 0 degrees Celsius, it will achieve the solid phase at atmospheric pressure. So more generally, changes in the state of a physical system, that is the phase transition. These transitions can be classified into first and second order phase transition based on the thermodynamic quantities behave during the transition. Okay, phase transitions are of two types, first and second order. Now we'll understand, of course, what are the first order phase transitions and what are the second order phase transitions. So what are the first order phase transition? Okay, one of the characteristics is they involve latent heat. They involve discontinuous jump at entropy or volume. Involves phase existence, like ice and water at 0 degrees Celsius. That means in latent heat, when the phase will change, latent heat must be there to induce the change of phase. That happens in first order phase transition. Volume or entropy both will change, not continuously but discontinuously. And in case of two different phases can coexist together at the critical point. What is the critical point? Suppose when water becomes ice, 0 degrees Celsius is the critical point, and at that temperature both ice and water do exist. So that is called coexistence of phases. So some examples, very famous example is the water example I have given. Melting of ice, ice to water, solid to liquid. Boiling of water, liquid to gas, I have already mentioned in the first slide. And liquid to solid transition in other metals, like if you cool down a metal, I mean the liquid state of a metal, it will become a solid. Similarly, if you melt the solid at its melting point, it will become a liquid. So these are examples of phase transition. And like I have mentioned, involves latent heat. When solid becomes liquid, or liquid becomes solid, or liquid becomes gas, so a latent heat is involved, like latent heat of vaporization. When water becomes water vapor, there is latent heat of vaporization involved. Okay, also there is change in volume, like liquid to gaseous phase transition. So suppose we have water, then we have gas, so there is huge change in volume. The liquid has less volume but gas has higher volume. Okay, the gas can speed to a larger volume as compared to liquid. So in that case, the volume change is discontinuous or sharp. And already mentioned at 0 degrees Celsius, or we have mentioned already, or at 100 degrees Celsius, both water and water vapor do coexist. So these are examples of first order phase transitions. Okay, also remember the characteristics. Now this very interesting picture. So water to ice conversion, ice to vapor conversion, vapor to water conversion, and water to vapor conversion, vapor to ice conversion. So that is possible in case of water. And here is the phase diagram of water, very interesting. So along the x-axis you plot temperature, along the y-axis you plot pressure. So this is the triple point you see here, this red dot, that is the triple point, means at this particular point all three phases of water coexist, and the temperature is around 0.01 degree Celsius and at 4.58 millimeter of mercury pressure. Okay, so we have three graphs mainly. One is this freezing or melting graph, like for the solid phase here, liquid phase here, and the gaseous phase here. So when the solid becomes a liquid, the process is called melting. When liquid becomes gas, so this is the liquid phase, this is the gaseous phase. Liquid to gas transition is called vaporization, and when a solid becomes gas directly, that process is called sublimation. Okay, you have to remember the processes. This picture is very important. And here one very peculiar thing you can see here, this one. So when you are increasing the temperature, the pressure is actually decreasing. Okay, increased temperature along this, pressure is decreasing. Why this happens? I just tell you one thing, that is due to the anomalous expansion of water. What is anomalous expansion of water? You must have learned in your lower classes, but let me revise it. So when water is cooled below 4 degrees Celsius to 0 degrees Celsius, the volume of water increases. Okay, volume of water increases, but for other liquids the volume of water will in fact decrease. So for water, remember once again, 4 degrees Celsius to 0 degrees Celsius, you cool it down, so its volume will increase instead of decreasing. Okay, on the other hand, if you like from 0 degrees Celsius to 4 degrees Celsius, if you increase the temperature of water from 0 degrees Celsius to 4 degrees Celsius, its volume will decrease. Okay, so I hope this much thing is clear to you, and that is why this particular slope is like, it is a negative slope. Okay, from mathematical point of view, this particular slope is a negative slope due to the concept of anomalous expansion of water. So 0 degree to here, if you go, then what will happen? Temperature increases, volume will decrease. Volume will decrease means the pressure will increase. Okay, now what is second order phase transition? So just the opposite. If the characteristics of second order phase transition are just the opposite to those of first order phase transition, so no latent heat is involved. Okay, unlike first order phase transition, no phase coexistence, the transition is smooth. Okay, so we'll come to the examples. So the transition is smooth, no phase coexistence. And second order phase transition involves gradual change in volume or entropy. Unlike first order phase transition, where volume or entropy may undergo discontinuous change or sudden change, in this case, even if there is change in volume or entropy, that will be gradual change. So for examples, these are the examples. You can pause the video here and check the examples. Ferromagnetic to paramagnetic phase transition. There is a critical point called QD point. Okay, this is a topic in magnetism we will discuss in future. Superconducting phase transition, like normal metal to superconducting state, another example of second order phase transition. Superfluid transition in helium-4. Helium-4 we discussed in the last video already, you can watch that video. So when helium, gaseous helium becomes liquid at 4.2 Kelvin and normal liquid helium becomes superfluid helium at 2.17 Kelvin, the phase diagram of helium you can check in the previous video. So that's all, friends. Thank you very much for watching this video. Once again, if you are studying thermodynamics, or you'll be certainly studying phase transition. Also in condensed matter physics, in higher classes you will study this topic, but in condensed matter physics some mathematical derivations or mathematical analysis is also involved that we may discuss in future. But for today, I hope the lecture was useful. You have understood the lecture, what are first and second order phase transitions with example we have discussed. Thank you very much, and I will soon see you in another video.